Hi everybody, and welcome to Unit 5 Part 3. We're going to finish out your notes for this unit with something that are called net ionic equations. All right, net ionic equations are actually going to be something if you decide to take AP chemistry next year or as a senior, you're going to deal with a lot. We're just going to touch upon them now and then revisit them probably at the end of the year. All right, I'm only going to be asking you for net ionic equations when we're dealing with double replacement reactions at this point. Okay, so we're just going to focus on that. So you're going to follow some steps, and I'm going to quickly go through those, and then we'll do an example together. We're going to write the double displacement or double replacement reaction like we normally would. If your compound is soluble, meaning it's aqueous, we're going to write it as ions. If it is insoluble, okay, you're going to keep it together as a compound. We're going to cross off anything that is exactly the same on both sides of the arrow. These are called spectator ions. The ions that don't change. And then we're going to write what's left over. Okay, so let's take a look. Let's go ahead and do this. Sodium hydroxide, NaOH, plus copper 2 sulfate, CuSO4. This is actually the reaction that you saw happen in the lab. All right. Okay, so double replacement, I'm going to end up producing, okay, CuOH2 and sodium sulfate. I'm going to use my solubility rules to determine what is aqueous and what is a solid. All right, so just to kind of give you a little clue if you haven't figured it out, the two that you start with will always be aqueous. All right, I also know this because all sodium compounds are soluble, so they're aqueous. Sulfates do have their own rule here, but copper is not one of the exceptions, so that is always aqueous. Okay, again, I know that my sodium compounds are always aqueous, so there you have it. Copper 2 hydroxide is your precipitate. Hydroxides are insoluble unless they're with alkali metals or ammonium. Okay, and that's rule number 5. So this is your solid. This is your precipitate. Okay, this is what is known as your overall equation or your molecular equation. And I'm going to write this in here. And this is how the practice sheet calls it. So this is just a regular equation. We do need to balance it, 2 in front of the sodium, and then I think we're good to go. All right, I've written my double replacement reaction. I'm now on to step 2. I'm gonna write all soluble compounds as ions. So what does that look like? Well, sodium hydroxide is soluble. So instead of writing it as sodium hydroxide, what I'm gonna do is write it as an ion. So I'm gonna go 2Na plus. Now I don't need to use these aqueous signs anymore just because it's gonna get too messy. Plus 2OH minus plus Cu2 plus, and the charges are important, plus SO4 2 minus is going to give me, now my solid I leave as a compound, right? Insoluble product as a compound. CuOH2, okay, that stays together. And now I have 2 sodiums plus a sulfate. All right, great. Okay, so I've done step 2. Step 1 is done, step 2, okay, and step 3. We're going to now cross off anything that's exactly the same on both sides of the arrow, and these are called spectator ions. So what's exactly the same? 2 sodium ions, 2 sodium ions. So those get crossed off, okay. Oh, sorry, just to give you a little terminology on your, writing them this way with all of the ions is known as the complete Ionic equation. This is how your practice sheet's going to call it. That's with all of these ions. Now we're going to cross off anything that's a spectator. So sodium is a spectator. Hydroxide, I have hydroxide on the left. Oh, but it's part of a compound on the right. These are not exactly the same, so that stays it there. Copper, same thing. I have a copper ion on the left. It's part of a compound on the right, so I can't cross those off. Sulfate, however, is exactly the same on both sides. All right, So now you write what you are left with. So I've crossed off everything, write what's left over. And that's gonna be, and I'm just gonna switch these so it looks a little prettier. Cu2 plus 2OH minus is gonna give me CuOH2. And that is what is known as your net ionic equation. Okay, right here. All right, go on ahead, pause the video and do the same thing for the next example, and I will do it as well. All right, final example for this unit. So I have silver nitrate plus lithium carbonate. All right, and that's gonna give me silver carbonate plus lithium nitrate. Okay, I do need, and this is a 2 here because silver's +2, carbonate's -2. Don't forget writing formulas, okay? So what I need is I need a 2 here and a 2 here, and then I think I'm good. My lithiums are good, my nitrates are good, my silvers are good, fantastic. All right. So I need to determine what my precipitate is. Remember, I've told you that the first 2 that you're starting with, they're gonna always be soluble. So you wanna look at your products. All right, silver carbonate, that's gonna be it. Carbonates are part of Rule 5, all right? Except for those in Rule 1, carbonates are insoluble or not soluble. And silver's certainly not group 1 or ammonium. So that is my solid. Lithium compounds are group 1, they'll always be soluble. So all of these are aqueous. Okay, and that is your, remember, your molecular equation or your full equation. All right, let's turn these into ions. So if I'm aqueous, that means I'm going to break up into ions. 2Ag plus 2NO3 minus, remember that 2 gets distributed, plus 2Li plus CO3, 2 minus, make sure you keep the proper charges. Now my silver carbonate stays together. It's my solid that I formed. That doesn't break up because that is a solid. That's gonna be a chunk in the bottom of your test tube there. All right, but my lithium nitrate is aqueous, so 2Li plus 2NO3 minus. Okay, all right, so this is your complete ionic. All right, then my next step is to cross off anything that occurs on both sides. Silver, well, no, they're not the same on both sides, so they have to stay. 2 nitrates, that gets crossed off. Remember, those are called spectator ions. 2 lithium ions, they get crossed off. So then what am I left with? 2Ag plus CO3, 2 minus is gonna give me Ag2 CO3, and that is my net ionic equation. All right, we'll have plenty of practice with this. Thanks so much.